Okay, good morning, everyone. My name is Deepak. I'll be your host for today. I think we'll just get started with the introduction as people join in, and then they can join us for the proper presentation. So today's webinar is called NB-IoT and LTE-M Solutions with remoteEye Platform. Today's agenda is something like this. So I'll be your host. But with me, I have a co-panelist in Sriram. Sriram is from Singtel, and he works in the IoT department, and he'll give his own proper introduction later on. But we will start with his session where he will introduce to you what NB-IoT is, what LTE-M is, and where would you want to use these technologies. And after his session, then we will move on to my session where I explain about our remoteEye platform and how it leverages these NB-IoT and LTE-M technologies to build applications for industrial and commercial applications. Right, so we will keep this interactive. So there is a Q&A box which you can use to ask your questions. So we'll take the Q&A at the end for both Sriram and my section. So do use that. We will be also doing some polls in between. So I'll be asking you some questions just to understand where you're coming from, what you're looking for. And then we will try to use the results of those polls to address your concerns. Right, so let's see. So we have enough people. I think we can get started. So maybe we'll start with a poll and to understand what is your awareness of NB-IoT and LTE-M technology. So let me quickly launch the poll. Yeah, so you should see a poll. I'll let it run for a minute or so. So maybe you can give your responses. So the question is, what is your understanding level of these technologies? So option one is you have deployed solutions using this technology. Option two is you know about it, but you have never deployed anything. And third is, I mean, you have never heard of it, and this is the first time you're going to use it. So let's wait for a few more seconds to get everyone's responses. Yeah, a few more people, if you can just vote in. Yeah, thank you. I think we'll wait for another 15 seconds. Yeah, so as of now, it looks like a lot of you do have some understanding about NB-IoT and LTE-M, but have never deployed it. So maybe, and there are quite a few of you who do not have an understanding. So I think both the sessions will be really interesting, and maybe we'll get started with that. So let me just close this poll and then move on to the next part. So I have Sriram with me. I'll let him introduce himself. But he will be speaking to you about NB-IoT and LTE-M technologies and what are the offerings that Singtel has to offer in Singapore. So Sriram, I'll pass it to you. Maybe you can share your screen and get started.
Do that. Good morning, everyone. Let me just get my material here, then I will talk to that as well. Again, okay, my name is Sriram, been with Singtel for the last 11 years and been responsible for M2M IoT business for the last 6+ years. You know, my responsibility is to look at the whole end-to-end product side of things for all aspects of IoT business, predominantly focused on connectivity, which is our core, but also I also have additional responsibilities for 5G now. We will touch upon that as well. So, you know, solutions is run by one of my colleagues, but then I support him from an overall productization aspects of it as well. But I'll quickly go on to a quick introduction and just to give you some perspective of what we're doing as part of our IoT business. I would like to always start from the bottom. You know, connectivity is the core. As you can tell, telcos do thrive on connectivity. Of course, back in the days when we were looking at IoT or rather for us to be able to kick off into a campaign about IoT almost 3-4 years ago, we were looking at various different technologies even from a connectivity perspective, right? Cellular being the core for us, but we were also considering other LPWAN technologies for IoT, be it Sigfox, be it LoRa, all of those were considerations. But then we stuck to the core because of the advent of what came in the industry. I'll touch upon that. But of course, as I say, everything starts with the connectivity. 3G, 4G, used to be 2G. We shut down 2G, as you all know. And of course, the timing was a bit bad in Singapore because we couldn't really capitalize on the technologies such as NB-IoT and CADM in the right time. But then we did launch those services 3 years ago. So that's still our core, I would say. We also do what we call as a drop-in IoT connectivity with an industrial gateway option for certain projects, which we do. One of the other key things which we also focus on the connectivity side is the regional connectivity, because just to explain this a bit, of course, cellular connectivity is used in this in the context of different projects in Singapore, be it government or enterprises. It's a given. We work very closely with the partners like SpaceAge Labs and other customers as well. But then when we look at this from a regional proposition, Singtel is actually a founding member, part of what we call as Bridge Alliance, which is a consortium of 34 operators in the region, out of which 14 to 16 operators are in Asia Pac itself. And all of us have an option to offer what we call as regional local connectivity, in multiple countries. This is not roaming. It's not the traditional roaming. Of course, we could do roaming anytime, but this is something which we offer on a local connectivity, which is domestic individual connectivity from operators on a common connectivity platform, right? So this is something which we're doing at scale right now. This is something which is new. I just wanted to give you that perspective, because what's happening in the industry is the big, large OEMs, the global OEMs are obviously wanting to come and deploy IoT applications in this part of the world. And as you know, Asia is a complex region with multiple different operators, different regulations, languages, culture, everything. To be able to unify that is something which is not an easy task. But as part of Bridge Alliance and Singtel as a lead operator, we're actually championing some of those initiatives in this part of the world, and then bring connectivity more on a regional basis for the end OEM. So some of the interesting use cases which we are working on right now are providing connectivity to connected cars. That's one vibrant use case, I would say, which is happening in this part of the world. And as you can imagine, connected cars is just not concept of telematics where the vehicle information is being sent back to the platforms, but it goes beyond providing infotainment services and things. So, and of course, we're also starting to see other OEMs, be it in the medical area, industrial area, different kinds of applications where they want connectivity more on a regional basis. They don't want to be contracting with each and every operator in the region. So that's why the model is for them to talk to us as a single point of contact, and then we do the heavy lifting of doing this, offering this connectivity on a regional basis. That's core. Of course, as part of connectivity, we also offer the option of securing the connectivity. As we see as an operator, this is more seen as a value-added service, because connectivity is provided in two different flavors. There are customers, enterprise customers, government agencies who will look for more private-based connectivity. Once it hits the mobile network, the data is sent back to those private data centers. So obviously, combined with our MPLS offerings in Singapore, we are able to offer that connectivity to those customers who need that private. But majority of the customers use internet for their applications. The applications are either hosted in the cloud, even if it's in the data centers. They use internet as a mechanism to allow access to those applications. What that basically brings sometimes is, depending on the device, edge device, which has this connectivity SIM card plugged in, depending on the processing capability, this may or may not have the best security options. Of course, when we provide connectivity through internet, we don't expose any public IP addresses, so there's no vulnerability for attacks directly. But then, internet-based, cybersecurity-based attacks are, in varied kinds, and it's not something which is going to be foolproof all the time. So one of the reasons why we offer the option of what we call as Connectivity Plus, I will touch upon that in slightly more detail later, but that's something which is value added, which we offer to the market as well for deployments which are on the cloud, customers wanting some kind of VPN and things like that. So we'll touch on that. We also have our own platform, which is called as Singtel Elements, which we use for some of our IoT projects, solutions which we offer. As you can see, some of the applications listed, fleet management is a very mature application in Singapore context and even for Singtel. Some of our core areas of focus, I would say, is working on smart locks and what we call as access control as a package. We've done a few projects. We're actively doing some projects for some of the bigger enterprises at this point of time. This is a combination of IoT connectivity plus, bringing smart locks aided with either NB-IoT and or other technologies. We also provide the platform to be able to integrate access control using video as one of those mechanisms. Facial recognition is obviously very, very popular now. We actually used to do video analytics as a standalone service in the past, but that's something which we were probably a bit ahead of time. We didn't find success that time, but now it's coming back in different shape and form. So, video-based applications, video-based access control, some of those things are something which is also core for us. The other high-level, large-scale project which we do is solar monitoring, which is end-to-end, which combines capabilities of bringing IoT gateways, connectivity, IoT platforms, and also the whole visualization of that data for one of the bigger solar operators. And the deployments which we're talking about is all on HDB rooftop solar. So we work through the solar company. We enable them with the solution for them to monitor, but also provide this data back to the agencies as well as the customer themselves. So this is broadly the scope of what we are focusing on as IoT. And of course, from a Singtel perspective, while the focus is predominantly in Singapore, we also work very closely with Optus in Australia, who is our fully owned subsidiary. Some of those applications we do, some of the solutions we do here, we kind of replicate in Australia as well. Just to put a bit of focus on the connectivity side of things, which is the core point of discussion today. I would, this is a slide, for some of you all, it might sound very basic. For some of you all, it might find interesting. For me, it always is interesting because, this is a slide which I always use and I also talk to, because when we always look at connectivity technologies and specifically when you talk about cellular, we also look from a point of how cellular evolution has happened. Of course, what you can see here are different technical terms of what this is all about. When we are all normal consumers, and if you're not tech savvy, we don't look at what is the specification. We just, as a consumer, we will just look at speed and capability and processing of the handsets and things like that. But down under, when you look at the specifications about the modem category is very, very important. Of course, I'm not talking about 2G and 3G here specifically. But then when you talk about 4G as a technology, which has been there for a few years already, when we originally had the first 4G handsets, it started with Cat4 modems as such. Obviously, your speed was advertised as 150 meg. Today, we are anywhere between Cat 18 to Cat 20 modems, supporting anywhere between 1.2 to 2 gigs bandwidth as such. And of course, 5G is coming. There's enough hype about 5G as well, which we're also going to be involved deeply, as you possibly saw some of those announcements. But as you can see, there is the high-speed flavor, very consumer-driven, where there is requirement for bandwidth, be it for industrial applications and or for even gaming and other aspects of it, right? But that's where the flavor of 5G comes into in the future. But when we have a high-speed flavor and you see the technology improving from a silicon perspective, obviously 3-4 years ago, there were, the low-speed mission-oriented technologies, which were also, standardized. This is the time, I would say, 2014, 2015, we did, Singtel, we did evaluate Sigfox and LoRa as an operator before NB-IoT and LTE-M was even talked about. Of course, at one point of time, we kind of decided to look at LoRa as one of those options because it provided some flexibilities and openness and things like that. Fast forward 2015 or late 2015, we already started hearing about the technologies about LTE-M and Cat-M1, and NB-IoT. So as a strategic move, it was decided not to go for other technologies. We decided to go with cellular technologies, which obviously would provide us better leverage on our investments. Obviously it's a technology which is powered by cellular, it's mass scale, international presence, very standardized. So it's something which was very natural, no brainer. Of course, as you possibly see, the whole industry, the whole world, all the operators move towards either launching NB-IoT and or LTE-M, otherwise called as Cat-M1. These were launched globally. We decided to launch both technologies together in Singapore. It just provided flexibility for us to offer both technologies. We also looked at this at that point of time. When 2G was shut down, as I was saying, the timing was not perfect. If the 2G shutdown had happened a little longer or later, customers would have had the capability to migrate to probably Cat-M1 as a technology, because most of the applications do not need even a 2G speed, technically, or 2G speed is more than enough actually, right? 3G was an overkill for many of the industrial IoT applications, so to speak. So it was just, I would say, wrong timing, unfortunately, but it's a done deal, so we can't complain about it. But the whole aspect of it is for us to be able to realize those two technologies. Of course, devices, takes time to come into the market. And I think all the technologies, even LoRa and Sigfox, while they were there in the industry for quite some time, they also went through this whole cycle about bringing devices into the market. And it took almost 3 years, probably if not more, to get these devices into every market. Of course, some of the global markets got this much faster. Asian markets, some markets got it earlier. So this was that challenge. And I think we went through the same kind of so-called challenge where, devices with NB-IoT and LTE-M were not necessarily available in the first couple of years. I think it's much more visible now. It's much more available right now. That's where it gets very, very interesting. Needless to say, obviously the biggest factor, these devices bring is that the cost of the module inside the device, right? Just to give you an analogy, LTE Cat4 at least used to cost almost anywhere between 60 to 80 US dollars at one point of time. I'm sure it is much cheaper now, but it's still expensive compared to what you can talk about. 3G modem was probably in the range of 30 US dollars. And now then you talk about almost 50% of that is $15 is what it costs for a LTE-M / NB-IoT modem. And it can go downwards towards $5 depending on the volume and things like that, right? So that's the scale of what it is. So obviously reduce device costs. Why would you want to invest in devices which is more expensive? That's the whole fundamental about that. The technologies also aid for improved coverage because it provides some inherent capabilities, which we will touch upon, which gives you, better coverage, for industrial applications, for remote devices to be able to send data and things like that. Improved battery life, although truth to be told, I'm as skeptical as most of you all. Battery life will get better as the technology improves, but it has promises about how. And it's also behavior of how the application works. It's not improved battery life because battery life cannot be improved by just powering on the devices and keeping it active. There are some capabilities which the device needs to be able to support. The network supports to be able to conserve power. That way you save battery, right? That's how it works in the whole equation of things. But this is the perspective as where we started this game on, right? I'll just switch gears to just give you a perspective of the connectivity offerings here, and then touch upon some of those key points here. As I said, broadly for the connectivity side, IoT Connect is actually the flavor of what we provide as a managed connectivity option. We provide a platform to be able to lifecycle manage different rate plans, manage data pools. We offer various kinds of data pools options, flexi and fixed. Flexi is more based on the concept of how many SIMs you add and how much the pool increases based on the number of SIMs you add. The fixed pool is independent of the number of SIMs you have. Again, not to confuse you now, but different pool options, very flexible. It's not like your consumer model where I have only 2-3 different plans. I can only offer that. So in enterprise, obviously we offer much more flexibility. You have real-time management capabilities from the platform. You have options to configure on the platform for notifications, alerts on usage, business rules, when do you want to do what kind of thing. These are very base, for somebody, most of you all, you're working with Singtel, you will know this already, but I'm just pointing this out. The other flavor I talked about is the IoT Connect Plus, which is concept of software defined network. It still gives you the base option of doing a SIM level, diagnostics and the other management on the IoT Connect Plus. But IoT Connect itself as an offering. IoT Connect Plus is actually a value-added service, which gives you that additional feature. So technically, you get base connectivity, but if you want to enable IoT Connect Plus as an option for certain projects, you can do this as a value-added service. I will touch upon, I have a couple of slides which I will talk about that. From a technologies perspective, we support 4G, which is LTE. 3G is still around. If some of you all have questions about 3G as a technology, it's expected to sunset probably sometime in 2023, 2024. It's something which is on the cards. Many of the operators around the globe are also starting to look at shutting down 3G, or some of it shut down 3G. Some operators still have 2G on, because some of these big geographies, they run a lot of devices on 2G. And it's technically for us, it's a sunk cost. Yes, you still have to maintain those 2G networks, but because of the nature of missions, they still have 2G, while these guys have also launched LTE-M and NB-IoT, depending on the region. 3G shut down. And of course, we will go through the same motion. If you look at it, cellular technologies are also very much driven by the consumer motion, right? The volume is driven by the consumer motion at this point of time. As these technologies, NB-IoT and LTE-M and the future versions get more prominent in the industry, some of those legacy or the old technologies will fade away. We will not need such things. And of course, at one point of time, we envision IoT devices, which will be much more than consumer devices, so to speak, right? So that's what we're envisioning. With 5G, there will be a different flavor as well. Of course, both technologies are supported on the network in Singapore at this point of time. For us, the perspective is this, NB-IoT is suitable for applications technically where your data transmission is limited on a daily basis, because that's how the concepts of battery conservation comes into picture, right? You don't want to have a chatty application with NB-IoT. If you're expected to send data every 5 seconds or even less than a minute, it's still very chatty, right? NB-IoT is not the best preferred technology, although it will work, just that it's not the most ideal technology. If you look at the devices, most of the modules come with the dual mode, right? I mean, they have LTE-M as well as NB-IoT. So it obviously makes it better to use LTE-M if your application is a bit more chatty, more interactive and things like that. Just to put some analogy in the application, let's take metering as an example. Some of you are all possibly very familiar with these kinds of use cases, because utility is one of those prime use cases globally for such technologies, right? Because you're going to have meters deployed everywhere out in the wild. And as long as you have cellular connectivity, you're supposed to be able to power that and then be able to transmit data. But you take metering in as a use case, water metering and electricity metering works completely differently, right? So that's where the technology choices come to picture. If you're just sending basic reading and some parameters from water meter kind of devices, NB-IoT is more appropriate, right? But in an electricity meter, it's much more than just meter reading. There's a lot of profiling which they do on the power line itself. I'm not discounting water metering doesn't require a lot of data, but comparatively, you look at it, the use case is slightly different. So it is not where, you just pick a technology and just use it blindly. The application, the relativeness of how frequently you need to see the data, how frequently you need to visualize that data, all of that matters. So for the first time, you will be surprised. I mean, this is something which we were scratching ourselves back then and said, Cellular mobile operators never cared about what applications are used in the industry. We offer a 2G, a 3G, a 4G. We give you connectivity, we forget. That's kind of what the nature was. But for the first time, 3 years ago, when we launched these technologies, we had to think, we had to ask those questions. We had to get knowledgeable ourselves, be able to ask those right questions to say, this technology is more suitable for this kind of an application, right? So that's where it opened up even for us, the learning and the capabilities to improve from our side. And 5G is also another flavor, right? It just pushes the boundaries much, much more than what it is all about. And as I say, 5G is coming. And the good news is that NB-IoT and LTE-M will be part of 5G as well, because it is already backward compatible. Because if you look at 5G was built on the principles of 4G, technically speaking, because 2G to 3G was a big drastic change. 3G to 4G was a complete drastic change. 4G to 5G is still a drastic change, but the principles are similar. So the backward compatibility is already there. GSMA is already committed that this is on the standards, and it will be available in the future as well. Just to give you some perspective of the features, of course, we are on the base features we run today. It's on release 13. Again, this is 3GPP release 13. We're getting ready to launch release 14 features later this year, which improves bandwidth and also some of the other features which will come in the future. But of course, at this point of time, if you look at it, again, this is for some of the techies in the call, and you'll probably know this much, much better. I mean, I've become a partial techie nowadays, but I used to be hands-on before. But I think as you grow older, then you need to be wiser to pass the baton to others. But from a bandwidth perspective, why is this important for us also? Is because, as you can see, when we go and get these spectrum from the government, right? We pay for billions of dollars to the government to buy spectrum, and this is the global phenomenon, right? These are all licensed technologies. You need to buy spectrum from the regulator. The bandwidth utilized to run these technologies is much, much, much lower. So that's where the economies of scale come to picture as well, because we obviously are running 4G and now 5G. They will all be using similar frequency bands as we bid and get these spectrum from the government, right? But how we deploy this and what technologies we deploy, it also makes a lot of difference. Of course, when you can run these kinds of technologies with limited spectrum usage, it can provide services to the customer. It is both an advantage from a customer perspective. It is also an advantage for us because we can conserve and deploy more number of devices in the market. So that's why it also is important for us from a spectrum bandwidth perspective. The frequency band where we operate today, is obviously for LTE-M. We use band 3 nationwide, and for 900, for NB-IoT, we use band 8. Of course, we also intend to offer band 3 on NB-IoT for certain locations as well. That's something also work in progress. The way this is all deployed, of course, from a LTE-M perspective, it's in band. For NB-IoT is also in band. For us, our deployment is all in band. The 1800 or the band 3 will possibly be deployed on guard band. So we will have 900 megahertz or band 8 on in band, which is already deployed nationwide. As we deploy 1800, will be on guard band as such. This is the throughput speed which we offer today. If we get to release 14 on NB-IoT, at least it should bump it up to 100 plus kilobits per second. It's something which will come later. This is based on our testing with proper working devices. I've heard some interesting stories, but that the uplink downlink speeds are not as good as this, but it's something which we have tested. For us to be able to put something like this, we have to test it. If any of you all have not experienced such things, happy to take that comments, and then we'll take it back and see how we can improve that. But it should be working. This is based on our own tests. Coverage extension is obviously a feature, which is an important feature where you have a deeper penetration. Of course, this feature also has some limitations, I can say, because if you usually use what you call as this coverage extension and the extended, DRX modes of technologies, of course, your battery will have an impact as well, because it has to retransmit. The concept of this coverage extension and extended DRX is obviously based on retransmitting signals, which means there is additional cycles on the device to be able to retransmit or transmit. So the battery power consumption could be higher, but then it is a trade-off. You want deeper coverage, it comes at some price, right? It's laws of physics, you can't change much. Of course, the battery size, all of that also will matter depending on what you deploy. One of the other key points I want to bring up here is the voice support. Of course, we don't have it live at this point of time, but what is actually a promise, we are doing trials though. We're actually trying voice over LTE on LTE-M right now. We've tested with a couple of modules. It's something which there are some interesting applications coming up. One key focus in the future, let's assume 3G sunsets, and you talk about wearables, right? Today, if you look at it, some of the wearables do support 3G technology, and some are moving into LTE. But of course, the cost of wearable also goes high as you use a module which is more expensive. This will obviously change the dynamics, because the wearables, you will always have this low-end and high-end wearable devices, as you know. And as you get these LTE-M based wearables, voice will be an interesting phenomenon. Of course, just not for wearables. There could be other applications where you deploy LTE-M but enable voice support. We don't have a lot of demand, which is why we have not enabled this by default, because it involves investment without to say. But there are some active discussions about whether this can be utilized for some projects in Singapore context itself. But in the future, it will become mainstream, is what I hope. Which is why it's also interesting, from the technology perspective, LTE-M versus NB-IoT. LTE-M fits I'm a little biased myself, because I like to look at LTE-M as a technology, because it has a complete following of the LTE technology, but also provides capabilities such as voice and things in the future. And the cost of the device will be the same, or probably not as expensive as an NB-IoT standalone. So, again, depending on the application, but there is definitely a promise from an LTE-M perspective, personally speaking. But of course, NB-IoT has its good use case for large scale deployments and things like that, right? From a duplex mode, sometimes it will help depending on the application, but the general deployment is half duplex, but full duplex deployments will happen in the future. Okay.
Sriram, just a reminder, just 5 more minutes. Yeah.
Oh, I'll be done well before that. I just want to touch upon this. I can talk forever. Apologies.
Yeah. No problem.
So this is the other thing which I just wanted to quickly touch upon. Why is this important? As I said, when we offer connectivity and when it is not secure, because as I say, when you have IoT deployments, you will have constrained devices or more powerful devices. The constrained devices could be smaller form factor, not a very heavy processor. You can't really run technologies such as encryption. If you have a good IoT gateway, a router, you could obviously enable encryption. You can do SSL VPN or a IPsec VPN, which is typical in the industry. But when you have constrained devices, you want to deploy these devices, but you still want to make sure that this is secure. Because one of the things which happen in the industry as we speak with many customers is also, it happens in Singapore as well, and it happens globally. There's a lot of theft of SIM cards. People take the SIM card, put it on the device, and they start browsing. When it's on the open internet, customers end up paying overage because of that. It's because it's not very secure. It's open, right? What we bring as a service here is to control internet access. So technically, we give you the service where it's almost like what we call as firewall on a SIM, right? It is on demand. You can enable this for those devices or the SIM cards which you need to be on a particular level. It gives you granular control on the platform. It's almost like a firewall screen where you can go and say, what is my destination? If it's a server application at a port level, TCP, UDP, whatever, you can configure those things and apply that. So this particular SIM card will be forced to access only those servers, right? So which means it's peace of mind for your deployment, and it's much more secure. This is one use case. Of course, as we say, security and policy control. And obviously, we give you a self-service portal to do all of those things. What are some of the key features there? Again, I talked about IP access lists, right? You basically say where this device needs to talk to, and you can control that. Of course, there are deployments where they want to be doing DNS whitelisting. So basically, you say, I don't want to do IP access list. I want to do just on a domain name basis. You can do that. Which domains this device will talk to. So you can configure that. It is all very, very simple, easy. You don't need to be an IT expert. You just need to know the basics. You know the IP address destination. You can just configure it. You can actually configure data limit controls. In terms of consumption. You can do bit rate limiting as well. If you know the deployment doesn't need a lot of speed, you can do rate limiting on the platform on instantaneously. When you enable that feature, it's instantaneous on the batch of SIM cards. One of the other interesting requirements which also comes into equation is the hybrid option, or the VPN and or the hybrid option. There are deployments where the edge device needs to be able to connect securely to an intranet, the customer's data center, through some kind of a VPN. So we support both IPsec as well as SSL VPN into the platform. And at the same time, they want to have what we call a split tunnel. If you use a VPN client on your laptop, there's a concept about split tunnel, right? Or split tunnel is a general term in security where the most interesting or the secure traffic is tunneled to the enterprise intranet, while all the internet browsing or public internet facing applications can be split through the tunnel. So we offer that as a capability, right? There could be interesting scenarios. One of such deployments could be point of sale terminals, where there's you want a secure VPN into your corporate, but at the same time, some of the payment gateways are sitting on the cloud, and you want to have secure access to that. So you can do split tunnel on a SIM card basis, right? So this is something which we offer to many customers here. We have both large enterprises, banks, all of these customers for this platform. The reason why I bring this up here is also to provide, I'm not trying to market something. It is something, it's important as you deploy IoT projects. Sometimes when you're confused about security, what to do, there are options. Of course, not everybody will offer that, but it's something which is available, for you to take advantage of. And it's, as I said, it's a value-added service. It's not, if you want to use this only for a particular project, it can be done, and then you can recycle the SIM cards and use it for another project. So just giving you those options. Again, at a very high level, for techies, it's basically a software-defined network platform which is integrated to our mobile core, and it's all configurations are done from there. It's purely software defined, and then it is very scalable and redundant and scalable, from the point of the service itself. So we can scale this instance to multiple locations and offer. So concepts of 5G is all going to be software oriented, as we all know, and some of these principles will be talked about much at length at that point of time. That's all I have for now, but thanks for this opportunity. Happy to take any questions later.
Sure.
Thank you.
Thanks, Sriram. That's a really good session. So maybe let me share my screen now. Okay, yeah. So I think that was a great introduction about NB-IoT and LTE-M technologies. I see some questions in the Q&A, but we'll take that in the end. So maybe now I'll talk a little bit about what SpaceAge Labs does in using these technologies to work more on the application side, and specifically on how we use it for changing how we operate and maintain remote and distributed assets. So from our point of view, we design devices as well as have a software platform for the application side. But before just going into that, the quick overview of who we are. So SpaceAge Labs is based in Singapore, started in 2016. And our focus is on low power wide area networks such as NB-IoT LTE-M and other networks as well, like Sigfox and LoRa. So we have a team which does everything from designing the devices to the application layer, where we built algorithms and the IoT software as well. Personally, myself, I come from a background of sensors, instrumentation in oil and gas and water sector. And I love working in this intersection of hardware and software, which is now basically IoT. So these are some of our customers who we have helped for different business cases. You'll see some public sector customers as well as some private sector customers. Primarily, the applications are related either to some infrastructure monitoring or monitoring of people in remote areas. And I'll come to some of these as we go along. I'll do a quick poll here to understand what is your biggest challenge when you deploy IoT solutions, right? And I'll then explain how we are trying to solve those problems. So let me launch the second poll now. And I would like to have your feedback on what do you think. So I've just launched the poll. So the question is, what is your biggest challenge when you deploy IoT solutions? Is it availability of connectivity? Is it integrating device, connectivity, cloud, application? It's just too difficult or time consuming? Or option 3 is you want these devices and platform to be compatible with your existing software or hardware systems, and it's not easy to do that. Or number 4, it's about expertise. You don't think that you have in-house expertise to do this, so that's stopping you from deploying IoT solutions. So maybe if all of you can vote, I'll keep it open for a few more minutes. What do you think is your challenge? And then we can discuss about how we can address those. So another maybe 20 seconds. Just click on the buttons. Yeah, last 10 seconds. I think if you all can vote. Yeah. Okay, I think I'll end the poll here and maybe share the results with you as well. So you can see, I think the biggest challenge people have said is integration of device, connectivity, cloud, and applications is the biggest challenge, followed by the capability of integrating it with your existing systems. And third is connectivity. And then the fourth is, of course, the expertise. So I think this is a good response and something that I was expecting. And then maybe I'll now talk about how we are solving these issues, right? So whenever you start your IoT or digitization project, you start with some desired business outcome, right? And typically on the very left-hand side, you have an asset or a process that you want to optimize using these technologies. And then it goes through a couple of steps. And we are going to focus on the first step, which is about getting data in the right format for you to process. So that is what IoT is. We use sensors, communication, and some kind of platform to convert physical information into digital information. And then once it is available in a format that is easy to use, then you apply your algorithms or data science to really bring out insights and actions. So we'll focus on that blue bubble for today and how we actually use IoT to get you the data in the right format. So why do you need to monitor or digitize your assets? Primarily, it comes down to these 3 reasons. I mean, there are many business cases, but peace of mind, knowing what your asset is doing at any point of time. A lot of customers previously used to send people to do this, but now even in this post-COVID scenario with manpower cut into half, a lot of them are looking at automatically or getting data in real time from their assets. Second is uptime, right? So if you want to use the data that comes from your asset to be able to predict failures and to respond before that happens. Because if something goes down and you are on less manpower, it becomes even more a downtime and cost for you. And the third issue is, of course, cost. Both labor cost as well as efficiency costs can be improved if you have these kind of IoT solutions on board. So to address that challenge and to address the questions you had about integration and connectivity, what we offer is a complete sensor-agnostic, easy-to-use platform, which has the devices, which has connectivity from our partners like Singtel, which we bundle with our solutions, and also the application. So from your point of view, it's within 5 minutes you can deploy a solution, right? And we'll speak about how we do that in the coming slides. But I just wanted to give you an overview of that. It's a completely pre-integrated solution. So you don't have to spend a lot of time in putting together a system. So how does this work? So on the very left side, you have probably your asset, which is a sensor or a machine or a meter or a PLC or a controller. You either get the asset condition or location using our device, which is connected to that asset. And then we transmit the data over networks such as NB-IoT and LTE-M to our cloud. So our cloud is the main engine which stores all the data, which lets you manage all our devices on the field. It lets you run algorithms. And then, of course, if you want to share the data with other softwares, which was another point, we have APIs readily available for you to quickly do that. So that is quickly an architecture, and we'll see how it works. But just to give you an example, so this is an example. Maybe you have electricity meters already in your building or in your facility, and you don't want to reinvest in a new wireless meter, for example. So what you would do is you would connect your meter using a bunch of wires to our device. And our device is capable of reading some standard protocols which these meter suppliers provide and convert them into an LTE-M or NB-IoT signal and send it to the software, right? And then you can build applications on top of that. The good thing is the same device can be used for many other applications in your organization. So you might start with energy monitoring, but you could connect your water meter to the same device. You could connect your air quality sensor to the same device. You could connect your solar panel to the same device. So it's a multi-function device without any requirement for reprogramming the device. And we'll see how this works. So that is kind of the key value propositions, that your existing sensors, meters can be connected to the IoT. And it is very easy and multifunctional as well. In terms of connectivity, I won't go too much. Sriram has explained about this, but our devices work on NB-IoT and LTE-M networks. And one of the reasons we chose to roll this out is, of course, in Singapore, Singtel and other telcos are providing this network. And then even globally, if you're joining us from the region, you'll start to see telcos such as Maxis in Malaysia, Telkomsel in Indonesia, AIS in Thailand, Vodafone in Australia, Telstra as well, and Optus as well. They're all starting to roll these out, and these networks are going to be around for a few more years, right? And they're being standardized to be part of the 5G standard as well. So if you are thinking about longevity of your solutions, you want the solution to last for another 20, 25 years. So this becomes important, right? So you can go and go to this website and check out the total coverage in all the countries that are there. But I just wanted to give you an idea that our solutions can work globally. So a little bit more about the hardware part to start with. So we have a device called the rEye IoT Transmitter. So it's an industrial sensor transmitter. How it works is you can connect different kind of sensors to it, and then, of course, convert it into NB-IoT LTE-M signal and transmit it. So it has inbuilt batteries, which can last up to 5 years. Again, qualifying depends on the use case. It could be anywhere from 6 months to 5 years, depending on how frequently you transmit, whether you're powering the sensor or not. So there are many variables. But it does have the capability of going into a sleep mode and preserving battery life. Of course, it is industrial grade, so it is waterproof, dustproof, and you can use it outdoors. It comes with an inbuilt GPS sensor as well. So if you want to know the location, you could use it. All the settings on this device are done using a mobile app. So it comes with a Bluetooth chip inside. So you can pair it with your mobile phone, and we provide a free mobile app for you to configure the devices. And of course, it is pre-integrated with Singtel's connectivity and our cloud. So you just have to turn on the device and the data is already on the software. So this is the app which you can download called the rEye IoT app. So as you can see, you can do both your network settings, protocol settings, as well as your sensor settings using this app. So you basically connect your meter, you choose what you want to read from the meter, say energy, current, using the application interface. You choose, I want to use Singtel's network, LTE-M, I want to upload every 5 minutes, just use the app, and within a few seconds, you're ready to transmit the information. So it becomes very easy for you. Now, the fundamental question comes is, okay, you've told us about this device. How does it work with the sensors? So if you look at applications, let's take water industry as an application. You have many different sensors that are used to measure either flow, level, temperature, pressure, maybe water quality, or to do metering, as Sriram was mentioning. So how do you connect all of these to the Internet of Things? So there are two ways you can do it. One is if there are already sensors which have inbuilt wireless connectivity, That is one way, right? You just buy that, you connect to Singtel's network, and then the data goes to your platform, and then you have it. But a majority of industrial sensors or meters are still wired. They give out some kind of wired output. So these are typically called either analog signals, digital signals, or serial signals, right? And that's where we come in. Our transmitter is able to connect to these sensors and then send the data over these networks to the cloud, right? So this is just to put in context the difference between integrated wireless sensor and what we are providing. So our device doesn't have any sensor in itself, but it acts like a bridge between the wired sensors and the IoT world. So quickly, I'll go through some of the type of sensors that we support. So broadly speaking, these are the 4 categories in which you'll find sensors in the market. The first category is serial communication. Serial basically means that there are 2 kinds of devices. One is the master device, which is our device in this case, and there are a bunch of slaves. So what happens is the master asks the slave, what is your reading? So in this case, you see this is a flow meter. So it measures the flow of oil or water, whatever it is. So there might be three flow meters where you want to measure. So you just wire all of them up to a single device. And every 5 minutes, it would ask, okay, what is the reading, and then transmit it. So this is very good when you have multiple sensors in the same area. You can quickly wire them up to a single device, and on the same timestamp, you can transfer the data to the cloud, right? This is just an example of how our device can connect to a flow meter. It can connect to an energy meter. It can connect to a leak sensor and a door open close sensor all at the same time, and then transmit all of these data together to the. So if you have use cases where you need multiple things to be read simultaneously, this is a really good solution to have. So similarly, there are sensors called analog sensors, which give out 4 to 20 milliamp or voltage signals. So we are able to read those and then transmit it. So example could be a level sensor on a tank. So this is the photo of a level sensor. So you would connect the level sensor to our device and then transmit that every few minutes as per your requirement. And simultaneously also have other things like a leak sensor near the tank if you want to. There are other sensors like temperature probes. So these are not for environmental monitoring, but maybe temperature in a boiler or in a freezer where it is minus 200 to plus 200. There you have these specialized temperature probes, and we are capable of reading the data coming from those probes and transmitting that data as well. In terms of water meters, there are a lot of water meters coming with wireless capabilities already, but if you have older meters, which are mechanical meters, there's a way of getting pulse signals out of them. So pulse signal is just an on-off electrical signal that the meter gives. So we are able to read that and transmit that as well. So this is good for retrofit scenarios where you don't want to cut your pipe and install a new meter. And we'll see some examples later on. So just to summarize on the device side, it's industry grade and waterproof. I've said that you can connect multiple sensors. And then one thing I forgot to mention was we have data logging as well. So I'm sure Singtel will provide amazing connectivity, but in case there is a loss of connectivity, which happens, we also log the data. And then as soon as connectivity is reestablished, we are able to send the data back to the platform for analysis. And of course, the device works either on a time interval mode, like every 5 minutes you want to do, or you can write some local logics and rules to do the trigger based on that. The data from all of this via NB-IoT and LTE network lands on our platform. So just to clarify, we don't own any data centers. So we use third-party data centers like AWS, Microsoft, etc., to host our software to ensure that it is secure, scalable, and highly available. So you could start with 5 devices, but quickly go to 5,000 devices, right? There's no need to set up any infrastructure. And the main things that we offer is, of course, managing all these devices on the ground, right? So that is very important. And then, of course, who are the users? Who's your organization? How do you want to store the data and visualization? And there are many things which I'll share in a bit. One thing I wanted to emphasize is that we also integrate third-party devices. We have seen that you cannot just say, I will only support my hardware. we understand that you might already have some devices that you want to connect to the platform. So we are open to connect our software to third-party hardware, as well as connect our software to third-party software, right? So both that flexibility is important in our eyes, and we provide that. So our software is available in 3 forms. It's available on the web, it's available on mobile, and it's available as an API, depending on how you want to use it. So maybe I'll quickly go through some of the features. So we have the device management part, where you can monitor everything from the signal strength, battery status, and all the device related diagnostics. Once you have installed the device on the field, if you want to do any changes to the configuration, you can do it from here, right? So you can do any changes to transmission settings or your sensor settings using that. And all the devices can be grouped, and the updates can be done based on grouping and sites or teams or projects, however you define it. Next is, of course, visualizing the data in an intuitive manner. So one way is map-based. A lot of our deployments are outdoors, and visual navigation is very important. So we have integrated, of course, with Google Map, and then some specific government maps like OneMap as well, where we can display the sensor data directly on that. And we have an alarm workflow as well. A lot of our customers want to see if something goes wrong. We need to acknowledge that event, log that event, and see what was the response. So that entire alarm workflow is part of it. And of course, there's kind of a search engine to search your various devices. We have some ready business intelligence tools as well. So for example, if it is meters, so if you define your data feed as a meter, it automatically generates a metering dashboard, right? So we have some such dashboards where we have pre-built, so that as soon as you define the data type, it launches that kind of dashboard. Rules and notification, this is very important, especially for the maintenance team. They want to understand what is happening with their assets. And a lot of times these people are not in the control room. They are walking around, and they would like an SMS, email, WhatsApp, a Telegram notification. So what we enable is that for every data point, you can write rules. And for every rule, you can set different recipients. And you can enable, disable this based on time and based on users as well. So this becomes very important for them to be notified immediately and respond as quickly as possible to the problem on the ground. Apart from that, we allow end user to build dashboards because we realize that every user wants a different visualization. They manage different assets. They don't want to come back to the vendor to do that. So we provide an easy drag and drop dashboard builder, which anyone who can operate a laptop can build. And then unlimited dashboards, right? So depending on which asset you manage, you can build those dashboards and have that view. If it is a mobile asset or it's a geospatial asset like a piece of land, then we have different kind of special dashboards for that as well. So if it's a moving asset, then we have tracking kind of visualization. If it is a geospatial asset, then we have geospatial visualization as well, as you can see. For people on the ground who don't have time to open an iPad or a laptop, we have a mobile app which we have launched both on iPhone and on Android, which you can download. And you can just have a quick view of the different assets that you have. You can set favorites, you can set notifications, so that you focus on the device that are assigned to you and not the entire platform that is provided. So how does it all gel together, right? So we basically promise a 3-step deployment. Step 1, you connect the sensor to our transmitter, wire it up. It's pretty easy to do. Step 2, use our mobile app and do the settings of the sensor, what you want to read from the sensor, and do the settings for the network. Step 3, basically it automatically gets added to your cloud, so you can just start building the dashboards. So within 10 minutes, you have deployed a solution, right? So you don't have to worry about that one big challenge that everyone said about integrating the device with the network with the cloud, right? So it's done very quickly. The next question would come, hey, I already have some kind of monitoring telemetry system. People call it SCADA. Some of you might have heard, supervisory control and data acquisition systems, or distributed control systems, or there are others. So how does this compare to that, right? So on the left side, you see a typical SCADA architecture where you have sensors, you have some local controllers, communication, there's some local server, there's a historian, and then possibly a connection to the internet, and then some kind of HMI or visualization. So on the right-hand side is the IoT architecture, which kind of simplifies it, where the sensors can connect to a node like ours, and then the rest of it is done on the cloud, right? So it becomes very easy. But the next question is, what if I already have SCADA? I don't want to throw that away. How do I still connect to IoT? So one way is you can go to your SCADA vendor and ask, hey, can I connect to this third-party IoT platform? But there can be many issues and it can take a long time. The other approach is you can have a parallel system, right? So you already have sensors which are connected to some local controllers. What you do is you have a parallel connection to our device, and then the data directly goes to the cloud. So you kind of bypass all of this and the issues around warranty and the issues around negotiating with the SCADA vendor and stuff. So this simplifies your job of connecting your existing sensors to them. The other possibility is if the PLCs are open and have standard protocols that we can use, we can read the data from there as well, right? So you already invested in sensors, you have invested in PLCs, then you don't need to reinvent the wheel. You just connect the PLC directly to our device and read it and send. So this kind of is a quick way of deploying IoT solutions in existing systems and retrofitting the solutions. So maybe I'll go through some examples now so that you can visualize how it really happens. So the first use case is with a manufacturing firm that had a lot of water related equipment that were consuming this utility. And they had issues around leakages, abnormal consumption, reporting to the regulator on their consumption, and everything was done manually. And they had meters already. So what they did was they connected the meters to our device, as I mentioned previously, using a bunch of wires. So it gives a pulse signal. And every 4 hours, we measure how much is the total water consumption, transmit it to our cloud, and do the further analysis depending on the business use case, right? So it simplifies them. They no longer have to do manual data collection analysis, and this can be submitted for regulatory purposes as well. Now, similarly, the same device can be used to connect to an energy meter and get data from that. So depending on the use case, you might monitor energy, current, voltage, power quality, XYZ. But in this case, it was a university campus that had hundreds of street lights outside. They didn't have a budget to buy smart street lights, right? So what we did was we connected our device to the electricity distribution box and monitored the current consumption of the different lighting zones. And depending on some variations, we could detect failure of lighting based on the current data. So if you have a lot of external lighting and no budget to replace it with smart lighting and want a retrofit solution, especially now when your facilities management teams are cut into half, you won't be going down there. So you need an automated system. So this would work there. This is at a theme park where they have a lot of water related exhibits and a lot of underground pumps, water pumps that need to be maintained well, because if the pump goes down, their top line gets affected. It's a water theme park, right? So previously they used to send people down to check the pump every few hours to ensure it's working, not leaking. But of course, with any manual effort, there is always lapses. So with this system, they were able to automatically get an early notification and then do corrective action before it leads to any major incident. Similarly, this is with another, it's a zoo. Basically they have a lot of water related exhibits and other exhibits which need monitoring. So before COVID happened, a lot of this was done manually. Now they want automated systems with a single view of all their external assets. And most of these assets are not connected because they're outdoors, right? So in this case, we are monitoring, I think, water level and probably water quality as well in the fish tanks, in the crocodile tanks, and so forth. This is more on the utility side. On the left side is river water quality monitoring. So river water quality is an issue, not so much in Singapore, but in regional markets, we have seen a big issue around pollution and knowing the source of pollution. So having enough water quality checkpoints becomes crucial. And on the right side is a more interesting use case where it is monitoring heavy metals in the sewer system. So there is this problem where manufacturing companies and other commercial companies illegally discharge chemicals into the sewer system. And previously, regulators used to go and do a manual sampling and check. Now with this system, it is completely automated, and a sample is also captured by the system to prosecute or to take further action. Right. So these are a couple of examples in a river and in sewers. This is more of managing the sewer network. So there are hundreds of kilometers of underground sewer networks in Singapore and in other major countries. And one of the big issue is choking of sewers or overflow of sewers because of various reasons. And right now, a lot of this is not monitored. It is pretty reactive. So what we are doing is trying to help some of our customers install sensors across the sewer network to monitor level, flow, and also compare it with other data points such as rainfall, the amount of buildings in that area, to give them an estimate of how the sewer is performing, and also allow them to predict an overflow scenario. So the best case scenario is that the sewer is going to overflow and take corrective action before it happens. So that is the use case that we are working on. And wireless is very good for this because it's completely outdoors. The sensors are actually installed under the manholes, and we are able to get LTE-M connectivity there as well, underground. So it's pretty interesting use case for a low power WAN solution. The same device and platform could be used to monitor equipment in your organization. So it could be pumps, it could be compressors, it could be motors, depending on the use case. So usually for rotating equipment, you would monitor energy, current, vibration, and skin temperature, and use that data to trend and see if something is about to go wrong. And of course, you could even integrate it with WhatsApp, and the machine would fundamentally WhatsApp you if something is wrong, right? Like I'm vibrating too much, maybe you can have a look. It could be the same system could be used for outdoor weather or air quality monitoring. I won't go into too much detail, but whenever the haze comes, this becomes a big issue. But what I'm trying to get at is you can use the same platform for multiple applications, right? And this is very important if you are a big facility owner, if you are a big industrial owner, you have many use cases, but you don't want to start your digitization journey with $1 million project, right? You might want to start with a 20,000 project monitoring pumps. So you can start with 5 devices, 10 devices, whatever it is, and then quickly scale to many more using the same system. So you don't have to reinvest in a second dashboard or a third dashboard and then end up with 5 dashboards monitoring 5 different systems. So we promise that you can put everything together on a single screen for your different kinds of assets. Second, it's, as I mentioned, it's completely from the sensor to the application. The amount of system integration time, the amount of people you need to deal with to integrate the system is also reduced, right? So that is another value proposition. And the third is it retrofits into existing systems, as I explained in a couple of use cases. And the final thing is, of course, it's compatible with networks, which are going to be around for the next 20, 25 years. And you don't have to worry about them going away too soon, right? So that is also important. And of course, low power wide area networks such as LTE-M are meant for machine communication. So that's what we offer. So that's kind of an overview of the remoteEye platform. I wanted to give you a quick preview on 2 new products that we are launching pretty soon. So we just spoke about remoteEye, which is a sensor agnostic platform to connect different kinds of assets to your digital platform. But we have 2 products coming up. One is called Trim. This is a very interesting product. It is probably the world's first real-time platform to monitor how grass has been cut in cities. And you might wonder why this is so important. But imagine in a country like Singapore, you have thousands of grasslands which are cut on a daily basis by hundreds of contractors. And there is no visibility of whether the grass was cut or not, or how well or how poorly it was cut. So this system would have a sensor which will be installed on every grass cutting machine. and in real time measure the height of the grass and the location of that patch of grass, and update an online system that would tell you how many hectares were cut, who cut it, when was it cut, how well was it cut, in which direction it was cut. So this can be used by contractors who cut the grass to manage their workforce, or it could be used by the regulator or the landowner to monitor the work that their contractors are doing and to automate, say, performance-based payment based on this system. This system will also be applicable to other outdoor work, such as cleaning of roads, spraying of chemicals, and many other environmental activities that go outside, done by contractors and not being supervised. The third product that we have, which is called Wobbler, and which is something we work closely with Singtel and Enterprise Singapore to launch, is called Wobbler. And maybe I'll spend a couple of minutes speaking about that before we go into the Q&A. So Wobbler is very simply put a GPS tracker which is very accurate, right? So typical GPS trackers are around 3 to 5 meters accuracy in terms of tracking an asset. This goes under a meter and sometimes at a centimeter level. So for use cases where you require really precise location tracking, this is what you would use. So how does it work? So the device would be installed on your asset. It would use NB-IoT or LTE-M networks to communicate with our cloud. So what we use is something called RTK technology to improve the accuracy of the device, location accuracy. So what our cloud does is it transmits these correction factors down to each device in the field and improves the GPS accuracy of our device. And then the device in turn returns the accurate location, which is available as an API for you to integrate, or you could use our application to manage or track your asset with this. So what are the potential applications? One application could be you could walk around with this device and build maps, right? So for example, you have a piece of land and the map of that land was built 5 years ago and recently nobody has updated it. So if you walk with this device on the fence or perimeter of that piece of land, in real time, we can create a map of that piece of land. And we are already doing this with the grass cutting use case and others, where you need to map the area you're going to work in before you start working, right? So that's one. Second is sometimes you really need to know where precisely you're maybe drilling into the ground or piling into the ground, or where precisely your personnel are to a centimeter level accuracy or a less than a meter accuracy. So that could be a second use case. And third is to actually quantify work, right? So in the case of, say, sweeping of roads, right? You have these machines which sweep the road every day. So if you mount a device like this on that, we can accurately know which part of the road they were cleaning. There are 2 lanes. We would narrow down to which lane was cleaned and which was not, and then quantify all of this performance in order to process payment or other things. So the key features, just to reiterate, very accurate GPS location. It also has Bluetooth inside. It can act like a Bluetooth beacon. So if the asset moves between outdoors and indoors, it can be used for that. It has some 9 or 10 inbuilt sensors, which can be used to build various kinds of logics. And of course, we use LTE-M network to transmit this data back to the system. So just to summarize, maybe to position ourselves, because you might have heard about IoT companies X, Y, Z, and SpaceAge Labs. So where do we fit in? So I think from our experience, we feel that a truly full stack or end-to-end IoT company needs to provide hardware, needs to provide software, and the capability to customize for enterprise or government customers. So that is the intersection in which we operate. So we design our own hardware, software, plus capability of customizing it as and when it requires, quickly and at a good price point. In terms of our strength, most of our team comes from water or oil and gas or industrial automation experience. So we understand the needs of industrial and enterprise customers. And of course, being from Singapore is good for us because Singapore is considered one of the smartest cities in the world. And the solutions that we deploy in Singapore can be replicated across Asia Pacific, which is our focus area in the next few years. So what we'll do now is we'll take some questions. So I think there are some questions in the Q&A box. So maybe we'll start there. I don't know whether Sriram, you can see the questions or not. There was one question from Mustafa. I think you have answered that.
Yes, I did. And it's an interesting question. So I think it requires lengthy discussion as well. But yeah, I did summarize to the best possible extent on here.
Yeah. So I think the question was related to 5G. So maybe just for everyone's benefit, can you just quickly explain the relationship between 5G and NB-IoT and LTE-M? Because there is some doubt around that. Yeah.
Sure. So as I was saying earlier, so 5G as a technology is built on 4G principles. And of course, if you look at these two specific technology, NB-IoT was actually not a core LTE technology, but it is something which was standardized, right? So that's the fundamental difference between NB-IoT and LTE-M. So LTE-M had very clear basics of how LTE technology itself works. So it's just the high speed and low speed flavor of it, right? But where the similarity comes for NB-IoT and LTE-M is the principles of how the device behaves and the network behaves for battery savings, how that extended coverage options are deployed as software features in the network. How does that handshake with the devices to be able to do transmissions or wake up the device to be able to send the data and things like that. All of that is kind of a handshake between the network and the end device itself. So from a technology future perspective, so as I was saying, 5G is built on 4G principles. Just that 5G brings additional flavors of how the new radio, what they call as in 5G terminology, the base stations are called as new radio. It's rather than calling LTE base stations, now it's new radio. I mean, every time you have a new technology, there's new fancy terms in the industry, as you can imagine, right? So the new radio will support, and then it also follows the 3GPP standardization process. Of course, the releases as they take software versions and look at features, what they are supported today. It is a continuum, which is why I'm saying, again, irrespective of the radio technology, whether it's 3G or a 4G or a 5G, there are similarities in terms of how the software has to be written, both from a radio and core perspective. Core doesn't change a lot, although the network core, what we call as mobile packet core, also is much different in the 5G arena. Although not to confuse concepts, but I will throw some interesting concepts here. So as we launch 5G, we have something called as NSA, non-standalone network, which means it's a hybrid of 4G and 5G. What that basically means is, from a base station perspective, it supports both 4G and 5G in the base station location, but it's still physically two different radios, right? That's how it works. Of course, these radios also support the software to provide NB-IoT and LTE-M. So if 4G is provided, LTE-M is by default provided. So it's NB-IoT is also a software capability on the radio. So which is why whether it's NSA or standalone in the future with full 5G radios, you have the software to run NB-IoT and CAT-M or LTE-M in the future as well. So it's just backward compatible. As the 3GPP releases progress, they have confirmed that these specifications will be available in the future releases. We're talking about release 15 and release 16, where all these will be mainstream. Release 16 is actually potentially the mainstream for 5G standalone or the complete 5G network in the future. But you can see technologies like as 5G and 4G coexistent for some time before 5G becomes completely standalone. So we'll probably take this for another day, but it's also an interesting topic. We're also learning, but that's the fundamental thought here.
Sure. I think that some of the questions are for me. So I'll start from the top. So Sarojini asked, does this device need programming to read data from the sensor? So as I mentioned, we have a mobile app, which makes it easy for you to read the sensor. So there's no programming required. So you use the app connected to the device and then choose the data that you need from that sensor. So we can, if you can reach out to us, we can give you, there are some YouTube videos available for you to see how that is done. The next question is from Angie. She's asking, may I know the maximum number of sensors you can connect via RS485 to your device? So the answer to that is a maximum 8 at a time, and each sensor you can read up to 15 parameters. So you can right now transmit around 120 parameters from a single device at any time. And it depends on your use case. You can choose how many from each sensor using the app. The next question is related to it. What is the maximum distance between the sensor to remoteEye? So depending on the wired protocol, so if it is an RS485 or Modbus protocol, the standard is 1,200 meters of wiring between the sensor and remoteEye. For other cases such as temperature probe or analog, it really depends, but it can go for a few hundred meters because it is high voltage signals. Having said that, I just want to emphasize that sometimes the cost of laying the cable is more than the cost of the device. So you might want to keep the sensor and the IoT device not too far away, because the whole point of this exercise is not to spend too much on cabling, right? So that is my answer to that. The next question is, how do you guarantee the battery life of your device? Will it be connected to power grid panels, any regular maintenance involved? So there are two power modes available. So you can either have inbuilt battery and power the device based on that. So we have a inbuilt battery counter. So we know at any time what is the battery life left. This is visible on the cloud, and you can set up alerts for the battery life as well. If you do have access to power supply, which is DC voltage, DC power supply, either from a nearby power source or from a solar panel, you can connect that as well to the device. So we have that option available. So it really depends on how you design the project and how long the battery life is expected. So if you're expecting a 20 years battery life, realistically don't expect it to come from the battery. Either you can put a bigger battery outside or have some kind of mechanism to provide power supply to it. So that's the next question. Next question is from Ajay. Can you provide details on security features of rEye IoT transmitters? So I think it's more on the protocol security. I think Ajay is asking is. So we use MQTT secure protocol for communications. The detailed security protocol description, I think, is available on the website, or you can reach out to us and we can provide that. But to answer that question, yeah, we use secure MQTT. Then the next question is, how about third-party integration with rEye IoT Cloud? So rEye IoT Cloud is available in two forms. One is the basic platform. So as part of the basic platform, it is only compatible with our own devices. But if you go for the enterprise IoT platform, then we have multiple connector options. So if your third-party gateway is a 4G gateway with MQTT or a LoRa gateway, then we can integrate it to the enterprise IoT platform. So there is a list of connectors available, which we support, and we can provide you that separately. So I think, Ajay, I will reach out to you separately for that question. The two more questions. How about the polling rate setting regardless of battery life? I'm not sure what this means, but I think the question is whether you're polling the sensors at a different frequency and transmitting the data at a different frequency. And in that scenario, how is the battery life optimized? So this is a good question, because sometimes you poll the sensor maybe 10 times in 10 minutes, then average the data and then transmit it once in every 10 minutes. So in that case, we have a mechanism where you can power the sensor through our device and control when you power the sensor and when you don't power the sensor, because the sensor itself consumes sometimes a lot of power. So we have that inbuilt mechanism of controlling when to power up the sensor and how to optimize the battery life. So I think that was the question, and I've answered that. So there are no more pressing questions here. If you have anything, okay, there's something just came through. I'm already working on a similar project where we measure energy using CTs and transmit it using Wi-Fi. Can you tell us the tech used in rEye? So I think you're using Wi-Fi, and as we explained, we don't do Wi-Fi products. We primarily focus on using NB-IoT and LTE-M. I think the question was, what modules do we use? So we have the product available on Quectel modules or on u-blox modules. So depending on the product and your choice or the region, you can use the different products. But just to mention, our rEye IoT transmitter works in multiple bands. So it works in different geographical zones. It works on NB-IoT, it works on LTE. And in countries where they have not launched these networks, we have compatibility with GPRS as well. So you can use it on GPRS network, and later if you switch to NB-IoT, you can still use the same device on that network as well. So I think that kind of answers Sridhar's question. I think we are running out of time. We're just about 1 o'clock now, so we will just wrap it up. We will be sending you a video recording of this webinar as well as our email addresses. So you can email us if you have any questions, and we'll take that separately. Thank you, Sriram, as well for joining this webinar and sharing your experience on NB-IoT and LTE-M. Thank you very much. Bye-bye.
Thanks all for listening.
Thank you.
Have a good one.